Today we're going to be exploring the graphical user interface section of the Python programming language, and we're going to be doing that using the Turtle graphics library. If you go over to the URL above here, just Google Python Turtle and go over to the official documentation of the Python programming language. You're going to see the Turtle Graphics Library. And from its introduction, they say the Turtle Graphics Library is a popular way for introducing programming to kids. You can read through it. You can actually do a lot using the Turtle Library. You can draw shapes. You can make little games with it. And in today's tutorial, we'll be doing a Turtle race. We're going to be building this, and I hope you're going to have a lot of fun doing it. It's good what we're going to be doing with it with the Turtle Library today. So without wasting much time, I'll see you at the tutorial. Welcome to Seed Media. So as usual, we got our Python file called race.py created with no code within it. And the first thing we need to do is reach out to the Turtle library and import from the Turtle library every. Basically, we're going to be making use of just the Turtle and the screen. We'll just import everything. Import. You can just import Turtle. You can import Turtle and the screen, so let's import the star. I'm also going to import the random module. Okay, let me expand this a little bit and make it bigger so you can see what I'm typing out. And the first thing we need to do is we're going to need to create a screen. Create a screen and say screen. Now you understand that we are calling from the Turtle module. So if let's assume we're importing, let's say we're just to say import Turtle, right? So if there's going to be Turtle dot screen, right? Okay, let's run that and see what we get. In order for us not to type this Turtle constantly, what we have to do is just take this out. We don't need this, and we import the Turtle module. So what we're just going to be having, know that every function we're calling from the Turtle module is supposed to have a prefix of the Turtle before we call it, but because we already imported the Turtle up here and called all the functions out of the Turtle module, we just have to type out the function name directly. So we're going to have screen.setup. We're going to give it a width. We're going to give it an attribute width of 500. Note that you don't actually need to write this width attribute. We're just writing it out for clarity's sake. And height of 600. Save that. I'm going to give it a title. We're going to give title. And title is going to be Seed Media Turtle Race. Yeah. Come down. I'm going to give the screen a background color of Bollywood. It's going to be a string. If you head over to the official Turtle documentation, you can find all this out here. For example, under overview, let's say overview of Turtle and screen methods available. You can see all this. If you type, let's say title. Yeah, that's the title I just typed out. You can see the Turtle.title as I explained earlier, but because we're already importing the Turtle directly, we don't need to prefix the Turtle to the function we are calling it. So that's basically the same thing for the screen. And for the colors, you can go to trinket.io.colors, and all the Turtle names are available here. All the colors you see here are available, and anyone you click on, you can easily use the Turtle name directly to work within the Turtle library. So we're going to have a color of Bollywood. If we run this program now, you see the screen will just open and terminate. To prevent the screen from opening at the bottom, we're going to have screen.exit on click. So meaning that the screen is only going to exit when we click on it. So let's run this. I see it stays. We click on it and it exits. And that height was a little bit more. Let's give it a height of 400 pixel. Save that. Let's run it again and see what we got. Yeah, so that looks okay. We need to generate the turtles. So from our previous video, we had a set of random color turtles. So we're going to create a list called colors. And the list called colors is going to hold the turtle colors available. We're going to have red, blue, green, brown. We have deep pink, and all these colors can be gotten from the trinket.io I showed you earlier. We're going to have purple, we're going to have teal, and chocolate. Let's save that. Okay, to understand how the turtle screen works, remember we designed a turtle screen with a width of 500 and a height of 400, and we have our X and Y position. On our X position, the center of the screen starts from 0 and moves, since we have a width of 500, and moves to the left to 250 and moves to the right of the X position at 250. But to the right we have positive values and to the left we have negative values, and the same applies for the Y position. Up starting from 0 up 200 we have positive value, and down 200 we have negative values. Let me click that and close it. So let's declare our Y position. For that, I'm going to give it a value of minus 160. Minus 120, minus 80, minus 20, have 20, 80, 120, 160. That's basically how we want the turtles to be positioned on the y-axis. Let's create an empty list we're going to use to house all the turtles that are going to be created and make changes to them. First, we're going to design the finish line. So we're designing the finish line first. We're going to say line values equals to, we're going to have sets of tuples within the list, and the first tuple is going to be Okay, now if you let's run this again before we do this. If you run this again, I will say towards the right edge of the y-axis, we want the lines to generate from top to bottom. We're going to choose values that will ensure that the lines don't exceed the y-axis and it doesn't exceed the x-axis, but it's just going to be within the y and x-axis. And the first line we're going to be generating is the black line. And we're going to generate the black line. We're going to give the first tuple of 280, 200, 9, and black. Just go along with this for now. And when we are done generating these values, you're going to see it work with the function and have a better understanding of what the tuple values are about. So let's give this white. So all these are supposed to be strings and these are supposed to be strings. White and black are supposed to be strings. Yeah, we'll save that. Up next, we need to create the function that's going to draw the finish line. And for that, we're going to say, okay, let's create a def, call it finish line. I'm going to pass, it's going to expect 4 values: the x coordinate, spacing, period. The period is how long we expect each of the lines to be drawn, and the line color that we're actually drawing. So basically what this is doing right now is that on the x-axis, this determines the coordinates or the position where we want the line to be drawn, and the spacing value determines where the line is going to start drawing for. And within the function, we're going to be decrementing the spacing values by about 40 to ensure that each line is not drawn on the same position. And within the function, we're going to have a for loop. We're going to say for position in range of the period. Yes, that's how long we expect the for loop to run. Box shape equals to total. So the total can be given a variety of shapes. So spacing minus equal to 40. So it's decrementing each of the spacing values by 40 to ensure that no two boxes drawn on the same line. Box shape, I'll just copy this out so I don't have to keep typing it. Box shape, speed 0. You can actually check out the Tortu documentation, and you're actually going to see that there are varieties of speeds attached to the Tortu diagrams and when they are being drawn and when they are actually carrying out activities. So you can check that out. So everything we're typing out here is actually gotten from the documentation, is not gotten off my head. I can say box shape dot go to. I want to go to the x value is going to be equal to the x coordinate, and the y value is equal to going to be spacing, and box shape dot color is also going to be equal to line color. So now how do we get each of the individual values that we want to make use of in this function? And for that, we're going to use another for loop, and we're going to say for values in line values. Yeah, on the finish line, we're going to use this to pass the values into, we're going to spread that out and get all the values that are within each of the tuples and within the list. I'm going to pick out each of those individual values and fill them out as they appear on the finish line function. So we're going to pick out each of those values and fill them out as they're expected to appear or expected to be accepted by the finish line function. Okay, this should be outside the function. So we can run this out now to test our code and see what we get. So it's drawing that out. It's drawing the lines because the pen isn't up. We need to move the pen up. Let's say box shape dot pen up. Let's test that out again. Let's make the width larger, 600, so we can accommodate for the diagrams we're drawing. Let's play that. The shapes are not drawing properly. Let's see what we made. Let's see if we made any mistake in any of the diagrams. We have multiple values being repeated. Okay, I see the problem. We have 280 should be. Yes, we need 240. Here should be 240 as well to ensure that it's not on the same line. Then we take on. Okay, we don't need this. Okay, so let's run that again and see what we get. Yeah, perfect now. Let's give this 8 as well. That should do the trick. Perfect. Okay, so we can move on to generating the total images that we're going to be working with. And for that, we're going to say, let's clear this out and say minimize this, and say we're going to say for the total values, we're going to say, let's say for index in range of 8, we're going to say totals equal to total. The shape is going to be total this time. And basically almost the same thing we have here, so I can just copy this out and I'm going to replace box with totals here. Move this to the same line. We also don't need the spacing here, so we can close that up. Now I'm going to change the go to coordinates. Let's say go to. I'm going to be going to, the total's going to move to minus 290. All the totals are going to start on the same x-axis, so we're going to be minus 290, and the y position now is going to be the y position an index. So basically we have a Y position up here, and each of the Y position is numbered from 0 downwards, and so it's numbered from 0 in an increment way. So basically when the range is going, it's going to start from 0 down to 7, and it's going to pick out each of those values and store in the index variable, and use it to select each of the values within the Y position list. We have the totals dot column, the column dot index, and the same applies just like the total dot the Y position index. Okay, we created a race total, perhaps wrongly spelled out, and that's going to use to hold each of the totals that have been created for the race. For each of the totals that have been created, we're going to say race total dot append. We're going to append each of the totals that have been created to it and store it within the list. We create the boolean variable of end race and give it the value of false, and say then check winner. The reason we're creating the check winner list is we're going to try to prevent having multiple winners at the same time. If more than one turtle crosses the finish line at the same time, then we can use the check winner to store those values and declare a draw. We'll say while not end race, while the value of end race is not true, we'll say for total in race total, so movement goes to random dot randint. Then I say without check if there is a winner, you say if total dot x coordinate is greater than 235. And remember that we have our finish line being drawn from 240. So we're working out from if 235, anything above 235, we have a winner of the race. So if coordinate is greater than 235, I say end race is equals to true. One can check winner dot append. So it's going to pick out each of the total that has crossed the finish line and add them to the winner and pen color. You know, we selected a color for each of the totals right now. And so what we're doing is when we append each of those totals, when any of the totals crosses the finish line, we're going to pick out that total and put it within the check winner, and it's going to be represented by its color. I want the total size to go up, increase in size when it crosses over the finish line. Because a total pen down and total movement. So now since the movement is going to be generated from between 0 to 1, we're going to pick up that value that is generated and use it to determine each of the totals movement at a specific time. You save that, I will go ahead and say outside the for loop now, say if end race is equals to true and len.check winner is equals to 1, we're going to say print f and say format it and say I'm going to convert it back to a string, join map str, I'm going to check winner. I'm going to convert it back to a string and write won the race. Only a single total crossed the finish line. lf end race is equals to true, check the length is greater than 1. And that print out and say the race. Print out say the race was a draw. We have no winner. As if more than one total crosses the finish line at the same time. And we can go ahead and exit the screen when we click exit. Yeah, so that's basically it. So let's test out our code and see if we have any errors. We'll correct it as it goes. Because the problem, function object is not subscribable, line 39. It's supposed to be colors.index. Yeah, so let's try that again. What again? What's the problem? Line what? Line 49. Line 49 says actually mistakenly called the variable up here. It is a function within the total library. So let's run that and see. It's showing us boxes. Okay, that's the reason. So one of all these mistakes, I'm just leaving them out. I could have easily just cut them out of the program and done it behind the scene, but it's good for us to just work together and see how it works in real life of writing software. Okay, so we have our total race and it seems like green has the lead. I'm rooting for green and let's see how it goes. Okay, come on, pop. Wow, green seems to have fallen back and wow, we have a winner. And it says down here that chocolate won the race. So let's close this out. So I'll clear the console, expand it up, and let's run it again and see. So I'm rooting for teal. At the top corner, just be below chocolate. And it seems like chocolate is about to win the race again. Come on. Wow, okay. Purple won the race. If any of this section of this code was a little bit confusing or probably I wrote it out too fast, I didn't give enough explanation, you can leave it out in the comment section and I'll address your question. Most importantly, I'll see you at the next video. Don't forget to subscribe and hit the notification bell. Thank you.